To describe an event in physics, it is first necessary to specify who observes what. This observer will be considered at rest at the origin of its reference frame. When the reference frame in question moves at a constant speed, we say that it is inertial. In this simulation of a kayaker descending a river, there are 3 observers and 3 separate inertial frames: the person on land, the duck in the water, and the person in the boat. When observing a phenomenon, each observer measures generally different velocities, but they are related to each other. For example, the person on the bank measures the velocity of the water relative to the land, v/t, which is also called the current. It also measures the velocity of the boat relative to the land, v/t. A duck, following the current, measures the velocity of the boat relative to the water, v/e. According to Galilean relativity, v/t is equal to the vector sum of v/e and v/t. In the simulation, the subscript notation is in French. That explains why they don't fit with the words in English. Let's start with a simple one-dimensional situation. Imagine that the kayaker is paddling at 1 meter per second to the right on calm water. v/t is then 0, and the duck in the water and the person on land should then measure the same boat's speed of 1 meter per second. If we add a current of 0.3 meter per second to the right, and the velocity of the boat relative to the water remains at 1 meter per second, the observer on land should measure a boat speed of 1.3 meters per second. Similarly, if the current is 0.3 meter per second to the left, the observer on land measures a boat speed of 0.7 meter per second. Finally, if the current is 1.3 meters per second to the left, the person on the bank will see the boat move backwards with a speed of 0.3 meter per second. The same principle applies to two-dimensional situations. In this simulation, the kayaker tries to cross the river to get to the red point on the other side. Imagine that the kayaker, able to paddle at a velocity of 1.5 meters per second relative to the water, wishes to reach a point 100 meters directly on the other side of the river. If the velocity of the water relative to the land is 0, he will point his boat directly towards the point in question. If the velocity of the water relative to the land is 1 meter per second to the right, and if he points his boat directly towards this point, the current will make him deviate from the desired trajectory. He must therefore compensate for the current by pointing his boat a little to the left. As the velocity vectors form a right triangle in this case, the velocity of the boat relative to the land will be, according to the Pythagorean theorem, 1.12 meters per second. Again, according to the Galilean velocity transformation equation, v/t is equal to the vector sum of v/e and v/t. It is very important here to treat velocities as vectors. It is incorrect to simply add the length of these vectors. Now imagine that the kayaker wants to reach a point 50 meters upstream. Here, the velocity vectors do not form a right triangle. By knowing an angle and two sides, we can instead use the law of sines or cosines to calculate the heading and the resulting velocity. In this specific case, the boat will have to follow a heading of 36 degrees to the left of the desired direction, and the magnitude of the velocity of the boat relative to the land will be 0.76 meter per second. The key in this kind of problem is to properly schematize the situation and the triangle of velocity vectors. If you are interested in the subject, you will find a link to this simulation and several others in the description.